started, what we're going to be looking at today, we're starting to look at some applications. We're going to begin with the graphs of the quadratics. So a quadratic has the shape that we call a parabola. Okay, so if you'll look at that first picture that you see there, don't mess with decimals quite yet. So if you look at that first picture, there's some key features of a parabola that we need to know about. So the first one that I'm going to label, you can't see anything. Let me turn the screen on here. There we go. Okay, so the first one we want to label on that first picture there is this point right here. What do we call that point? Why is it special? It is our y-intercept. Okay. All right. The next points I'm going to label here are these 2 points right here. Okay. Why are those special? What are those called? They're your x-intercepts. Or there's another word sometimes we use for them. I know that starts with Z. Zeros. So both of those are x-intercepts, or they can also be called zeros of the function. Okay. And then the last thing that we'll be interested in is this point right here. Okay. This point is what we're going to call a vertex. Okay. Your vertex can be a maximum or a minimum. In this case, we have a minimum, but in a different parabola that is upside down, it might be a maximum instead. And the vertex is that turning point of your graph. So these are the main things that we are going to be concerned with whenever we're trying to graph a quadratic. So the first thing I want you to do is I want you to graph these, and you can use Desmos here to graph these. And for each one of them, I want you to tell whether it opens up, like a smiley face, or opens down, like a sad face. Okay? So go through all of these, graph them on Desmos, and tell whether they open up or down. And I'm going to cut off the screen, and I'm going to graph these for those that may be watching this later, since we've got several out. But I'm going to cut the screen off so you guys can do it on your own. To type in an exponent, there are two ways. There's one that is easier than the other. So you can just, if you click that little keyboard, there's an exponent there. But I think the easiest way to do it is when you're typing, if you just do 3, and if you do Shift 6, which is that little caret key, it'll take you up into the exponent, so you could do something like that, although that's not what you want to type in. And if you do the arrow over, it'll go back down into whatever you need to type in. So for those who are watching, I'm just going to graph these for you. If you do second, shift in the 6, it's that key, it'll take you up to the exponent. Number 1, is that up or down? Up. What about 2? 3? 4? What did you guys get for 4? Down? I think it should be down. Yeah, make sure you typed in the negative with 5 right there. 5, you guys get up or down? Down. And 6, down. Okay, so just looking at the equations, how can you tell if it's going to be up or down? Okay, Tyler? Negative x squared. If the x squared term is negative, the parabola opens down. And some of them are easier to tell that than the others. Like the first 4 problems here, you can just look at the number in front of your x squared. Number 5, you could not. Number 5, you would actually have to distribute here. And if you did, you'd get 15x minus 3x squared plus 35 minus 7x. And then you'll see right there that your x squared term is negative. For that, you could combine those and simplify if you want, but you really just care about that x squared term. For number 6, you would have to square this out, x squared plus 6x plus 9, if we double square that, and then you distribute that negative 5, so you would end up with negative 5x squared minus 30x minus 45 minus 11. All you really care about, though, as soon as you see that you get that negative 5x squared, you know that opens down. Okay, so if you have a negative x squared term, it's going to open down. Positive x squared term, it opens up. Positive is a happy face, negative is a sad face. Without using a calculator, let's look at these. So if without using a calculator or Desmos or anything, number 1, Zoe, is that going to open upwards or downwards? Up. Okay. Adam, what about number 2? Is that one going to be up or down? Down. And Jaden, what about number 3? Up or down? It's going to be up, because when you start to distribute here, that 2x times x gives you a 2x squared, which is positive, so that's going to be up. Okay, so you probably did that in Math 1. You may or may not have remembered it, but you probably did that. So we can tell whether a parabola opens up or down just by looking at the equation. Here's the next thing I'm concerned with, the y-intercept on the calculator. And we're going to use Desmos. These are the instructions for the calculator if you want to look at that. But we're going to use Desmos, so graph all of these on Desmos and write down what the y-intercept is. And the good thing about Desmos is when you type it in, x equals x squared plus x minus 1. And we probably need to move this around here. If you click on the line, it'll show all the points where it intersects, so it'll show you exactly where that's at. So in case it's not perfectly on grid lines, you can still see what that is. So like for number 1, you get a y-intercept at 0, negative 1. Okay, test all those others out. I'm going to do these for anybody that might be watching the video, and you guys do this on your own. So, like, normally it's going to look like this. Sometimes, like, when you zoom out, it gets really skinny, and you don't really want it to be that skinny. Like, on this one, you can find it. It works fine. But if you want a better picture where you can see it where it's not quite so skinny, if you hit the little wrench over here in the corner, right here you can set your window. So, like, I don't want this to be quite so skinny, so I could make this maybe like negative 10. So positive 10 on my x-axis, and then not mess with my y-axis, and I can get a picture that's maybe a little bit easier to see there. So if you need to, that's always an option. A little wrench over there will let you change your x and y-axis. Okay? Alright, hopefully you've had a chance to look at least several of these. We did that first one together and we got 0, negative 1. For number 2, Zoe, what did you get? 0, negative 20. For number 3, Kayla, what did you get? Good. For number 4, Tyler, what did you get on that one? Good. Let's see. Stephanie, did you get number 5? What? 0, negative 28 is correct. Good. And Kason, did you get the last one? Good. So, we're looking for ways we can know this without having to graph it, because there will be some that I give you where you don't have to graph. What can you tell me how can you figure this out? Katie? Very good. So, like, if you have the form in y equals ax squared plus bx plus c, like we use for quadratic formula, the y-intercept is at 0c, whatever that last number is. Or, I want to show you something else, because that's really easy and definitely what you want to do for 1, 2, 3, and 4, right? For 5 and 6, you have to multiply everything out if you're going to use that method, which works perfectly fine. Another thing you can do for the y-intercept, let's look real quick at Desmos. Whenever I look at the y-intercept, what's the x-coordinate of the y-intercept? 0. And when I look at all my answers over here, the x-coordinate for all of these was 0, right? So the other thing that you can do is plug in 0 for x, because if you have a y-intercept, your x-coordinate has to be 0. So sometimes that's a little bit easier to do on problems like number 5 and 6. So rather than having to multiply the whole thing out, I could just do 0 plus 7 times 0 minus 4, which is 7 times negative 4, which is negative 28, right? Or on this one, I could do 2 times 0 minus 5 squared minus 12. So that would be 2 times negative 5 squared, which would be 25 minus 12. So I get 50 minus 12, which is 38. So if you plug in 0 for your x, it will give you your y-intercept as well. And the same thing's true up here, because if you plug in 0, like in number 1, 0 squared is 0, x plus 0 minus 1. So whenever you do that, the only thing that's left is that last number there. So let's do these next few. So if I'm looking at these 3 equations, you'll notice they're the same as the ones that we had before. But this time we're talking about their y-intercepts. Q, what would the y-intercept of number 1 be? Okay, 0, 6. And whenever you do these problems, you can give this to me either way. You can say 0, 6, or you can say y equals 6. It just depends on what you're looking at, what the answer keys will do with that. Let's see. Philip, what would the y-intercept be for number 2? Perfect. 0, 9. And then, David, what about number 3? What are we going to get for number 3? Okay, negative 20. 0, negative 20. Or we could say y equals 9. Or we could say y equals negative 20. Typically, I think they usually give you the coordinates more often. Here, in this one, you could multiply everything out, or you could just plug in a 0. Either way, you get 5 times negative 4, which gives you that negative 20. Okay, questions on those? I think those two are really, really easy to find. I think the next two that we're going to look at are a little bit trickier. Alright, so x-intercepts, we're going to skip all this calculator stuff because we are just going to use Desmos. I want you to graph these 4 and find their x-intercepts. Some of them, I think all of these have 2 x-intercepts. It's possible for them to only have 1, but I think all of these have 2. So, so graph these on Desmos and find the x-intercepts. I will graph these for if you're watching. So for number 1, you should get negative 3, 0, and 7, 0. Does that sound right? Okay. Alright. Does that look okay to everybody? Okay. On number 2, you should get negative 8, 0, and 3, 0. If you have x equals, that's okay too. Yeah. For number 3, we should have is it negative, I didn't write this down, negative 2, 0, and 6, 0. Is that what you get for those? Okay. And then for that very last one, when you graph it, the parabola is way down here, right? It doesn't cross the x-axis at all. So for that one, we're just going to say none. There are no x-intercepts. Okay, so if we look at these, and I think these are a little bit tougher to do, how can you find the zeros of an equation without using your calculator? If you look at those first two, what do you notice? Okay, so it's the opposite of whatever number you had here, right? So if you think of this problem, what are the y coordinates of all of our x-intercepts? 0, and they're always 0 because otherwise they wouldn't be x-intercepts. So y coordinate is always 0. So if I think of going up here to number 1 and plugging in 0 here, then I'm just basically solving this equation, right? So I'll have x plus 3 equals 0 and x minus 7 equals 0. So that'll give me x equals negative 3 and x equals positive 7. And there are my x-intercepts, right? Same thing would work for number 2. If this equals 0, then negative 8 and positive 3 are your correct answers. Number 3, I would plug in 0 for my y, or in this case the h of x. And what would I do with x squared minus 4x minus 12 if I wanted to solve that? It's a quadratic equation we're solving. We have several ways we can solve quadratic equations. What can we do? What? We can square root both sides in some cases. Will that work here? Okay, we could complete the square. We could do quadratic formula. Those always work. What's the easiest here? Factor. This will factor, so that's your easiest. So, or your fastest, I should say. So you'd have x and x. You're going to have a negative 6 and a positive 2 whenever you factor that. And then, so that means x equals 6 and x equals negative 2. Right? So all of those methods in the first part of chapter 3 that we're using for solving equations, we can use here. If I try number 4, if I plug in 0 for my y, I've got negative 2 times x plus 5 squared minus 20. And so what would I want to do for that problem if I'm trying to solve that? This is where we square root both sides, right? So we would first have to move the 20 over. So I'm going to move down here. So 20 equals negative 2 times x plus 5 squared. Then we will divide by negative 2. So negative 10 equals x plus 5 squared. What would I do next? Square root. When I square root negative 10, I'm going to get a plus or minus I square root of 10. Alright, and so if I move my 5 over, I've got negative 5 plus or minus I squared root of 10 is my x. Is that a real number? It is not, because I have that negative under the square root, so that's why I know this one's none. Okay, so our way to tell what the zeros are is plug in 0 for y and solve. If it's already factored, it's a lot easier to solve. If it's not factored, it's much harder to solve. Okay, questions? All right, let's look at these next ones. So this time we want to find the x-intercepts or the zeros of each one, but we're not using the graph this time. So whenever we want to find the x-intercept, we plug in a 0 for our y. If we can factor, that's what we want to do. Will this one factor? It will. We'll have x and x, negative 2 and negative 3. And then so whenever we get it factored, we set each one equal to 0. Each binomial equal to 0 there. So x equals 2 and x equals 3. If I want to write those as coordinates, I'd have 2, 0 and 3, 0. Okay, questions? Alright, for number 2, if I plug in 0 here, I've got 9 minus x squared. Hugh, what would you do to solve that? Okay, we can factor. How does it factor? Okay, which one needs to come first? No. Because of the order this is in right now, the x does not come first on this one. You'd probably get away with it. It wouldn't really make a difference because it's the positive and negative. But on some others, it might make a difference. So if the number's first, we can't switch the order for subtraction unless you want to move this stuff over to the other side, which you could do. But I would just do 3 and 3 here and do the x and x here. One's going to be positive, one's going to be negative. So it's best not to switch the order on those because it can cause some problems. And then if we set each one of those equal to 0, we've got 3 plus x equals 0 and 3 minus x equals 0. So here we'll get x equals negative 3. And here I would just move the x over to the other side. You get 3 equals positive x. So our answers are 3, 0 and negative 3, 0. Did anybody else use something different to solve that? You can use square roots on that one also. So if you do 9 minus x squared equals 0, you can just move your x squared over the top to the other side. So 9 equals x squared, and then you can square root both sides, which will give you a plus or minus 3 equals x. So that works too. You can if you want. You can, well, I just moved the x right here. I moved the x over here so I wouldn't have any negatives. But if you want, you can do negative x squared equals negative 9, and then divide by that negative 1 first. So x squared equals 9, and then square root both sides. Yeah. But any way that you choose to solve that, you should still get positive and negative 3. Okay. 3 is already factored for us, so that is good. So we will take each binomial and set it equal to 0. So 2x plus 5 equals 0, and x minus 4 equals 0. Some of you are having a little trouble with this because you just want to say it's negative 5, but you've got to set the whole thing equal to 0. So 2x equals negative 5, so x equals negative 5 halves. And then right here we'll get x equals 4. So we've got negative 5 halves, 0, and 4, 0 for that one. Yes? I don't really care whenever it comes to problems like this, as long as it is a decimal that you know the exact decimal for. So if you have something like, if you ended up with like 4/7, leave it a fraction because we don't know how to change that, and you have to round it off. It's going to give you like a long, crazy decimal, but if it's something like negative 2.5, that's fine. Either one's fine with me. 4 is already factored for us, so that's good. So we'll have x minus 3 equals 0, and 9 minus x equals 0. So right here we get x equals 3. Right here, I like to think of just taking that x and moving it over to the other side, which will give you 9 equals x. So here we get 3, 0, and 9, 0. And because she was doing the wrong ones, Katie asked if there was a possibility that you could only have one answer. And because she was graphing these right here. Let's look at this one. If we have negative 3 times x minus 4 squared equals 0. If we solve this, like I would solve this one like an equation, although you could graph it if you want. So if you divide by negative 3, you get x minus 4 squared equals 0. Right? Then you would square root both sides. And x minus 4 would equal, technically you should put a plus or minus with your 0 right here, but is 0 really a plus or minus sort of number? It is not. So all you really have right here is x minus 4 equals 0. So x equals 4. You just get one answer for that. If you graph that, this is what it'll look like. You've got negative 3 times x minus 4 squared. And what happens when you have a problem like this is that parabola is going to come up and just barely touch the x-axis, and that is also its vertex, and then it turns back around and goes the other way. Okay, questions on that? All right, we've got a couple more things to do. All right, all parabolas are symmetric, so they have an axis of symmetry. So if we look at this picture right here, where do our axis of symmetry, if I draw it in, I'll use a dotted line here, let's use a different color. If I draw in the axis of symmetry, if I want the line where I could fold this parabola in half, it would be right here. So the axis of symmetry is always passes through the vertex, and it's always halfway between the x-intercepts, if you have them. You have two of them. Okay? Now, there is going to be a problem. Did all of the parabolas that we looked at, did all of them have x-intercepts? They did not. So sometimes they don't have x-intercepts, and if they don't have x-intercepts, then we have to, if they don't have x-intercepts, I don't copy everything. Oh, no. Okay. If they don't have x-intercepts, then what we have to do is we have to use this formula. X equals negative b over 2a. Okay. So use this when you don't have x-intercepts. Or we're going to see there's sometimes it's just easier to use that anyway. But if you don't have x-intercepts, you have to use negative b over 2a. Okay? Alright, so without using a calculator, we're going to find the axis of symmetry. You'll notice I gave you the same ones that we just used. Right? So, so the x-intercepts, we just did these. The x-intercepts for these were at 2, 0 and 3, 0. Is that correct? Alright, so if we want the point halfway between 2 and 3, what is that? What is it? 2.5, right? So our axis of symmetry would be, and make sure whenever you do this, it's always x equals 2.5. X equals is a vertical line. I know that sounds a little bit backwards because the x-axis is horizontal. But x equals is a vertical line. If you're not unsure, if I'm letting you use Desmos, you can just type in. Let's type in the equation. We've got x squared minus 5x plus 6 is the one we're looking at, and x equals 2.5. If you graph that line right there, you can see it cuts that parabola perfectly in half. So you can check using that if you're allowed to use that in this portion. Okay, so I did that by just finding that halfway point between the x-intercepts. Notice I also could do this if I use that formula, x equals negative b over 2a. In this case, x equals negative b, you got negative 5, so it ends up being the opposite of b, all over 2 times 1. That gives me 5 halves, which is 2.5 as well. So you can use, if I didn't already have the x-intercepts, and the question didn't ask me about the x-intercepts, I may just want to use negative b over 2a for a problem like that. Okay? Questions on 1? On 2. The x-intercepts for that one were at negative 3, 0, and 3, 0. What is halfway between negative 3 and 3? 0. So our axis of symmetry is that x equals 0. Or if you use negative b over 2a, x equals, what is your b for this one? What? It is not 1. Because if we write this in order, we'd have negative x squared. We don't have any x's, right? Plus 9. So that would be 0, or negative 0, over 2 times negative 1, which is just going to give you 0 if you do that. So if you're missing that middle term, then that b is 0. Anytime you're missing any term, if you're thinking like quadratic equation, it's a 0 that you're going to use for that term. Okay, for 3, my x-intercepts were negative 5 halves, 0, and 4, 0. That one's not quite as easy to figure out, right? This is one case where it probably is easier to think of negative 2.50 instead of doing the fraction. How do I find the point halfway between two numbers? I mean, the other ones were just pretty easy to see, right? Halfway between negative 3 and positive 3 is 0. You can just picture that. Negative 2.5 and 4 is a little bit harder to picture. So how could we find the number halfway between two numbers? Let's say that Hugh, how tall are you, Hugh? 6 feet tall. And let's see, Zoe, how tall are you? 5'1". So if I want to know somebody that's halfway between them, what would I do? Add them together, divide by 2. I take an average, right? Like if I take Hugh and Zoe's average height, that's the height of somebody that would be halfway between them. So if I want to do this here, I'll add these together. 4 plus negative 2.5, which gives me 1.5. And I'll divide that by 2. What is half of 1.5? 0.75. Sometimes it really might be easier to use fractions there, like you would have 3 halves divided by 2. And so dividing fractions is easy as pie. Flip the second and multiply, you get 3/4. But that's you on that. So x equals 0.75, or x equals 3/4 is your axis of symmetry. Your other option on that is to multiply everything out, and then you can use negative b over 2a. For number 4, we got x-intercepts at 3, 0, and 9, 0. What's the number halfway between those? 6. So x equals 6. And again, let's say that you're having an off day and it's just not coming to you. 3 plus 9 divided by 2 is 12 divided by 2, which is 6, right? Just take the average of those two numbers. Okay. Now, the last one, all we had was an x-intercept at 4, 0. Alright, so I still have that one. No. Let's scrap that one again. Was it a 2 or a 3? Nah, 3. Doesn't make a difference though in this. So, if I only have one x-intercept, that means that my graph just went up, barely touched the x-axis and came back down. So what does that tell me about my x-intercept? It's also your vertex. So, in a case where you only have one x-intercept, that is where your axis of symmetry is. So axis of symmetry here is at x equals 4. Okay, questions? Alright, I know these are long notes today. We're almost done. I got one more thing we gotta know how to do. If you'll notice, maximum or minimum always lies on the axis of symmetry. So, if I know that my axis of symmetry is 2, and I can find that either by finding the point halfway between the x-intercepts or by doing negative b over 2a. If I know where the axis of symmetry is, how do I find the y-coordinate? I know the x-coordinate has to be 2, because it's got to be on that axis of symmetry. How do I find the y-coordinate? Let me show you this. Okay, the equation here is y equals x squared minus 4x minus 5. So let's say I plug in 1. It's not what I need to do here, but let's say 1 squared minus 4 times 1 minus 5. That'd be 1 minus 4 minus 5, which would be negative 8. So I found whenever x equals 1, y equals negative 8. Look right here. 1, well, the y these go by 3 right here. So this is negative 6. This is negative 3. This is 3, 6, 9. So 1, negative 8, that sure does look like that point right there on the graph. All right. Let's say plug in 5. Y equals 5 squared minus 4 times 5 minus 5. That gives me 25 minus 20 minus 5, which gives me 0. So that tells me when x equals 5, y equals 0. Look right here. 5, 0. It's a point on the graph, right? So anytime that you have an x coordinate, if you plug it into the equation, it gives you the y coordinate that goes with it. So we should already know right here that the x coordinate has to be 2. So if I want to find the vertex right here, then I'm going to plug in 2 into my equation. So I will have y equals 2 squared minus 4 times 2 minus 5. So I get 4 minus 8 minus 5. And when I do that, I get negative 4 minus 5, which is negative 9. So that tells me x equals 2, which I already knew was on my axis of symmetry, and y equals negative 9. So that's how I get this point here. Okay? So this I was up here. I'm just showing you when you plug in a number, you get the y coordinate. So plug in the axis of symmetry for x to get the y coordinate of the vertex. Okay, questions so far? Alright, so I gave you the same problems again, so we didn't have to keep doing all kinds of things over and over. So for number 1, we found our axis of symmetry was at x equals 2.5. Alright, so if I plug in, that means for my vertex, my x coordinate is 2.5. If I want that y coordinate that goes with it, I'm just going to say 2.5 squared minus 5 times 2.5 plus 6. And it's alright with me if you guys use your calculator on this. So, it's going to be 5 plus minus 5 times 2.5, 6. Should get negative 0.25, I believe. There, so you've got 2.5 negative 0.25 is your vertex. Okay, questions? For number 2, our axis of symmetry was x equals 0. So that means for our vertex, we're going to have 0 and then our y coordinate. What do I get when I plug in 0? 9. What else is this? It's the vertex for this problem, but it's also something else. It's also your y-intercept. So whenever your axis of symmetry is on the y-axis, your y-intercept is also your vertex. Okay. For number 3, our axis of symmetry was y equals, not y, x equals 3/4 or 0.75. So that means our vertex is at 0.75. We need a y coordinate. So we would say 2 times 0.75 plus 5 times 0.75 minus 4. It is fine with me if you use your calculator there. And I think you should get negative 21.125 for that. Okay, questions? Alright, for 4, our axis of symmetry was x equals 6, and so our vertex, to find our y coordinate, we just plug in 6. So that gives us 3 times 3. So we get 9. 6, 9 is our vertex. And then for our last one, our axis of symmetry was x equals 4. And so our vertex is going to be at 4. And if we plug in 4, we're going to get negative 3 times 0 squared. That's just going to give us a 0 for our y coordinate. Or our vertex is our x-intercept, which we already found, so that was also 4, 0. All right, questions? All right, almost there. All right, we need to put it all together. All right, so we need to find the direction each parabola opens, its y-intercept, its x-intercept, your axis of symmetry, and its maximum or minimum points. Okay? And then I'm going to add this, well, not correct. Well, yeah, let's sketch a graph. I always try to start with whatever I think is sort of the easiest to do. In this case, I think the x-intercepts are easiest to find because this is already factored for you, right? So if we set this equal to 0, you've got 2x plus 1 equals 0. So 2x equals negative 1. So x equals negative 1/2. And over here, we'll have 5 minus x equals 0. If we move that x over to the other side, we just get 5 equals x. So our x-intercepts are at negative 1/2, 0, and 5, 0. Okay, questions? All right, if we know our x-intercepts, we can find our axis of symmetry, right? It's just the point halfway between. So if we've got negative 0.5 and 5, we add them together and divide by 2, that's going to give us that halfway point. So that would be 4.5 divided by 2, which is going to give us half of 4 is 2, half of 0.5 is 0.25. So our axis of symmetry is that x equals 2.25. Okay, and then since we've got axis of symmetry, let's just go ahead and find our vertex. So my vertex, I know the x-coordinate is going to be 2.25. Q, what do I do to find the y-coordinate that goes with that vertex? We don't want our y-intercept. That's something different. We want the y-coordinate that goes with this vertex point. We know the x-coordinate is 2.25. How do we find the y-coordinate that goes with this x-coordinate? Okay, anybody know? What do we do, Kayla? You plug in for x in the equation, okay? Because if this is the x-coordinate, if you plug in any x-coordinate, then that gives you the y-coordinate that goes with it. That's true for any point, not just the vertex. But since we already know that this is the x-coordinate, because that's on our axis of symmetry, then we can plug it in. So if on our, I'm going to use the calculator on this because we're starting to get to some ugly numbers. So if we do this, we'll have 2 times 2.25 plus 1. Make sure you close that parentheses. And that'll be times 5 minus 2.25. And we're going to get 15.125. So 15.125. Okay. So x-intercept, you set the y equal to 0. Axis of symmetry is halfway between your x-intercepts. The vertex, the x-coordinate is always your axis of symmetry. You plug that number into the equation to get your y. Normally, our y-intercept in our direction of opening is pretty easy, but for this one, since it's not multiplied out, it's a little tougher, but not too bad. We can either multiply this out, or we could just plug in 0 for our x. And if we plug in 0 for our x, we will get 1 times 5. So we get 5. So our y-intercept is 0, 5. And then for my direction of opening, if I think of multiplying this out, whenever I multiply these two terms, that's where I get my x squared, and that's going to give me a negative 2x squared. So that tells me that this opens down. So I really did, you may want to do this like over to the side or on the back or something. I really didn't give you a lot of room for this, but let's sketch a graph of this. And when I say sketch a graph, it does not have, I typically don't make you label your y-axis. Just label your points. So if I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You pretty much just want to graph these points. So you've got negative 1/2, 0. That would be here. And 5, 0. That would be here. The axis of symmetry is at negative 2.25. So that would be, positive 2.25. So that would be about right here. You don't necessarily have to draw that dotted line, but I like to include it. The vertex is on this line, and its y-coordinate is 15.125. Because sometimes you get big numbers here, I don't make you label that y-axis, but we're just going to put this point up here somewhere. And then I've got the point 0, 5, so as my y-intercept, so that's probably like right here somewhere. Maybe a little higher than that, but pretty close to that. And I know this opens down, so if I think of drawing my line through here, I've got this. And then I like for you to label those points. So you've got 5 zeros here, negative 1/2, 0, 0, 5, and 2.25, 15.125. Questions? It's a lot to put all together there. Okay, and then we're going to do this last one. Now this one, I always like to do what is easiest first. So this one, it is pretty easy to tell me which way this opens. Let's see, Tracy, does this open up or down? Up. And the y-intercept is also pretty easy on this one. Tyler, what do you get for your y-intercept? 4. So 0, 4. All right. For your x-intercepts. For x-intercepts, we plug in 0 for our y, so we'll have x squared plus 5x plus 4, and we want to solve that. If it'll factor, that's usually our best bet here. Will this factor? Okay, it'll factor into what? X plus 4 and x plus 1. So that means, what do I get for my x-intercepts? Negative 1 and negative 4. So my x-intercepts are at negative 1, 0, and negative 4, 0. Now you got a couple options for your axis of symmetry. For your axis of symmetry, you could look at the point halfway between, which is not too bad. Or, in this case, since I do have this solved like this, sometimes I'll use x equals negative b over 2a for this. So if we use negative b over 2a, we'd have negative, b is 5, over 2 times 1. So we'd get x equals negative 5/2, which is, if you want to use a decimal instead, negative 2.5. Or you could add these two together, negative 1 plus negative 4, divide it by 2. You're also going to get negative 5/2. All right, questions? Last thing is our vertex. And since we found our axis of symmetry, I already know the x-coordinate is negative 2.5 or negative 5/2. David, what do I do to find the y-coordinate that goes with that? We just plug it in. So we're going to say negative 2.5 squared plus 5 times negative 2.5 plus 4. And if we do that, we are going to get negative 2.25. Okay, questions? All right. So all we we need to do now is sketch a graph. We're almost done. So 1, 2, 3, 4. If you got pretty small numbers on this, if you want to label your y-axis, you can. So if I graph the points, I have x-intercepts at -1 and -4. I have a y-intercept at 4 over here. I have an axis of symmetry at -2.5. I will have the vertex at -2.5, -2.25, so maybe somewhere about right here. And this opens up, so if I graph this, it'll look like this. And then I like for you to label all those points, so you would tell me this is -4, 0. This is -2.5, -2.25. This one right here is -1, 0, and this one right here is 0, 4. Questions?